Hi, everybody. Welcome back. We are still talking with Dr. Tom Granoff because he is full of wisdom and love getting his perspective. And I asked him today to give us just a quick explanation of the difference between correlation and regression, because sometimes, at least in my mind, they sometimes feel very similar, but they're different. And so I want to just take a few minutes to talk about that. So go ahead, Dr. Granoff.
Thanks. Let's just start with a quick review of correlation to begin with.
Okay.
Correlation is the relationship between two variables.
Okay.
And it measures the extent the relationship resembles a straight line. Textbooks will talk about linear relationship, and you may, back in the day in your stats class, you may remember there was a scatter plot put up on the board or the screen, and then a line of best fit was put through the dots. And the more the dots cluster on the line, the stronger the correlation. And in the behavioral sciences, there's two basic patterns we look for. Positive correlation, you can put in your notes the same direction. Negative correlation, you can put in your notes as opposite direction. Okay. Example of a positive correlation, there's a positive correlation between how much education somebody has and how much money they make.
Yep.
If they have a fourth grade education, they're not going to make much. High school diploma, they make more. College degree, they make more. Graduate degree, they make more. As one number goes up, the other number goes up. Positive correlation, same direction.
Okay, makes sense.
Now for negative correlation, the pattern that all adults know is the relationship between how much exercise you get and the size of your waistline.
Yeah, okay.
I know in my own life, when I get lots of exercise, I slim down. When I don't get much exercise, well, let's just say there's more of me for my wife to love. I think all adults know that pattern.
Yep.
Okay.
Yep.
All right. So correlation, we're looking at two variables. And my examples, positive was education and income, and the negative correlation was exercise and waistline size.
Yep.
Now,
makes sense.
When we do regression, there's two kinds of regression that we're going to talk about. What's referred to as linear regression.
Okay.
And multiple regression.
Okay.
Now, linear regression is basically just Pearson correlation. You may remember from algebra class back in the day, y equals mx plus b. That's literally all you're doing. And so you have one predictor in linear regression, and you're comparing it to the criterion or outcome or dependent variable, depending on what you're going to call it.
Okay.
And what the regression model does is it creates a prediction equation, and then it takes the predicted score compared to the actual score, and it does a Pearson correlation. So in linear regression, you get a large R, which is exactly the same as the Pearson small r.
Okay.
So for linear regression, you just have one predictor variable.
Okay.
Multiple regression, like the name says, you have multiple predictors. And then what happens is the model creates a prediction equation, takes all of those, so it's y equals mx1 plus mx2 plus mx3 plus mx4 and whatever. We solve it algebraically. We have a predicted score, and then we do a Pearson correlation between the predicted and the actual. That's literally all multiple regression is a fancier form of correlation.
Okay, interesting. So it's still showing basically the same result. It's just doing the calculation a little bit differently.
Yes.
Behind the scenes. Okay.
Now, for dissertations, if you only have one well, like anything, there's pros and cons.
All right. It all depends.
It all depends. If for linear regression, G power says you need a sample of 55.
Okay.
If you do Pearson correlation, G power says you need a sample of 84.
Interesting.
gives the exact same result. Now, my doctorate is in clinical psychology, so I can tell you how I feel about G-power, but I don't know the underlying math as to why it's 55 or 84. But literally the p-value and the regression coefficient are exactly the same.
So you could choose to do linear regression if you're worried about your sample size.
There you go. So there's that. Now,
Interesting. Okay.
if you do it as linear regression, typically they want you to have a regression table, which takes up a whole page. If you do it as correlation, you just have a correlation coefficient of point something something. So, so let's say you're doing five different comparisons. Let's just say you're looking at, I mean, the famous study that seems, I get probably about 20 of them a year, is supervisor leadership and employee satisfaction.
Yep.
Good bosses have happy employees, basically.
Right.
Okay. So if we do, for example, if we look at leadership and we look at something like the multi-factor leadership questionnaire from Bass and Avolio, there's a total of 15 different scale scores that are generated from that thing. So you could do that as 15 regression tables, or you could do it as one table that has 15 correlations on it. And it gives you the exact same answer.
Right.
However, the correlation coefficients have a whole lot less typing.
Right.
And they're all on the same page. So if you did, for in fact, compare all 15 MLQ scores against, job satisfaction, I would probably do the table and sort the correlation coefficients from low to high, or high to low, I should say.
Oh, interesting. Yeah. Because that'd be a quick visual comparison.
Right. Because usually, I mean, I don't know about you, but when I see a table of numbers, the first thing I look for is what's the biggest and what's the smallest. So if you can organize that for the reader, that tends to help there.
Yeah. It's interesting. Things to consider when you're,
I'm sorry?
It's things to consider when you're looking at correlation versus regression and the approaches for your particular study.
Yes.
Wonderful. Thank you for that. I appreciate that.